Hey guys, Mr. Backerberg here. In this video, we're going to look at Pythagorean identities. Now, as we're looking at our Pythagorean identities, there's actually going to be three basic Pythagorean identities, but then we're going to be able to use rearranged forms of those to help us come up with other Pythagorean identities. So the first Pythagorean identity that we're going to take a look at says the sine squared of theta plus the cosine squared of theta equals 1. And like I said, we're going to be able to rearrange this equation to kind of come up with other Pythagorean identities. So one way that I could rearrange this equation is by subtracting the cosine squared over to the other side. And if I did that, then my equation would say sine squared of theta equals 1 minus cosine squared of theta. A different way that I could rearrange this top identity in here would be to subtract the sine squared over instead. Then my identity would say cosine squared of theta equals 1 minus sine squared of theta. Now my next Pythagorean identity says the secant squared of theta is equal to 1 plus the tangent squared of theta. And again, I can rearrange this to get different forms of this Pythagorean identity. So one thing I could do is subtract this 1 over to the other side. Then my identity would say tangent squared of theta is equal to the secant squared of theta minus 1. Or if I wanted to, I could subtract the tangent squared over. Then my identity would say 1 equals secant squared of theta minus the tangent squared of theta. And my last Pythagorean identity says the cosecant squared of theta is equal to 1 plus the cotangent squared of theta. And again, I can rearrange this by moving pieces around within this equation. So I could subtract the 1 over to the other side, and then I could write it as the cotangent squared of theta is equal to the cosecant squared of theta minus 1. Or I could subtract the cotangent squared over to the other side, and my identity would say 1 equals the cosecant squared of theta minus the cotangent squared of theta. Now we're going to start using these identities to help us do a little problem solving. And what we're going to start off by doing is we're going to find the sine of theta and the cosine of theta if we know that the tangent of theta is 5 and the cosine of theta is greater than 0. Now, based on what we've got, we are given some information about the tangent. And if we think about the different identities that involve the tangent, the one that I'm going to use first is the one that says the secant squared of theta is equal to 1 plus the tangent squared of theta. Since I know that my tangent value is 5, I can plug that in on the right-hand side. So then my equation would say the secant squared of theta is equal to 1 plus, we know the tangent is 5, but this is supposed to get a squared on it, so I have to square that. Now on the right-hand side, 5 squared is 25, and if I add 1 to that, then I'm going to get 26. So I would get the secant squared of theta equals 26. Now if I just want the regular secant, then what I have to do is square root both sides in order to get rid of the squared power. So the secant of theta is going to equal plus or minus the square root of 26. Now we were asked to find the sine and the cosine, but I can actually use this secant to help me out because one of the reciprocal identities that we talked about said that the cosine of theta is equal to 1 over the secant of theta. Now we just figured out that secant of theta was either plus or minus the square root of 26. Earlier, we said that we wanted the cosine value to be greater than 0, meaning positive. So as far as these roots go, I'm going to ignore the negative root and only focus on the positive root. So my cosine of theta is going to be 1 over the positive square root of 26. Now I could clean this up and rationalize this and end up getting the square root of 26 over 26 as my answer. Now that takes care of finding the cosine, but I also wanted to find the sine of theta. Now one of the other identities that we talked about was a quotient identity that said the tangent of theta is equal to the sine of theta over the cosine of theta. Now if I think about rearranging this, I'm trying to find the sine, so what I could do is multiply that cosine over to the other side. So then this would say the sine of theta is equal to the tangent of theta times the cosine of theta? Well, earlier on we said the tangent of theta was 5, so I can plug that in for my tangent of theta. And I just found my cosine of theta to be 1 over the square root of 26. So if I multiply these together, I'm going to get 5 over the square root of 26. And again, I could rationalize this if I wanted to. I could multiply that square root of 26 up to the top. So I would get 5 root 26 over 26. That's going to be it for this video. Thanks for watching.